My name is Ololade. I'm one of the co-founders of DevOps as a Service, daas.ng. Daas.ng is a Nigerian-based mentoring platform, which have been set up. We established it, and with one major goal is to raise up and mentor next generation of DevOps practitioner. We've been on for a while, and all of our mentees have been part of our sessions for several weekends now. We started with introducing people to what is DevOps, what does it involve as a practice, as a tool, and the skills. And we've been doing all these. It's interesting to know that it's been for free. We are charging nothing. We just want to find a way of bridging that skill gap we see happening in our country, Nigeria. And it's just a way of giving back to the society, ensuring that we're able to encourage and mentor as much as possible people that have interest in the DevOps practice, and not just to those have an interest. We want to equip them with the right set of skills, and try to motivate them such a way that they can also get to disrupt their own space, innovatively. And this afternoon we have one of our faculty leaders that will taking us on the beat and bite of microservices. You're going to see how much of microservices can be, and it will be taking us through the architecture. What does it really mean? And give us a better understanding of microservices, how it can be applied, the advantages and the risks. And this afternoon we have joining us is Ololade Oyebanji. He's a software developer in UK with Nest UK. He's going to be taking us through the session, and I want to employ us that we'll give him a virtual ovation as he takes the floor to give us an introduction to microservices. Ololade, over to you.
Thank you very much, Sean. Good afternoon, everyone. Hope you can hear me very well. To be sure.
Good afternoon. We can hear you.
Okay. I don't want to be like that professor that was talking for like 30 minutes. I didn't realize that no one was listening to him. Okay. I'm really honored to be here and to share my brief knowledge on microservice. So the idea is to try and make this thing as hands-on as possible with very little slides. I'm someone that I really don't like slides. I like more hands-on. So I'll try and see if I can achieve that. And yeah, I'll share my screen soon, and we'll kickstart. All right. So microservices. So my name is Ololade Ahmed. I've been a software engineer for about 7 years. I've done software support. I've done user support for a number of years. So I've kind of touched a lot of some areas of tech. And one of the areas that I've also touched is microservice. So that's why I want to give a hands-on explanation, introduction to microservice. So what are microservices? Before we understand microservice, it's best we even understand what are monoliths. Then by the time we understand what are monoliths, then we'll be able to better understand what are microservice. And also, in trying to keep it hands-on, I'll do a short demonstration of a monolith and also do a short demonstration of a microservice. And I will also try and make sure that I use very basic words, not the key terms for now. I use the basic words and the key terms just carry over. Others that are very, very new to, probably some that are totally new to tech entirely. So what are microservices? Microservices are micro services. It's just as simple as that. The word micro is just like one simple small thing, and then service Service is something that does something. So microservices in plural are like pockets of services grouped together to achieve one end goal. So what do I mean by that in terms of tech? So we know several apps that are currently on the store right now. Uber, um, maybe Bolt, and several applications are on the store right now. You as a user, you know that you would onboard on this. So let me take Uber as an example. So you onboard on Uber, you enter username and password, and then you are in. And then when you are in, you order for a ride. And when you order for a ride comes, and then you take the ride, and then you do that. But what you don't know is that there are services that are powering all of these things behind these things that we don't know. Now, so let me give you a graphical example of how an Uber application is. So I'm showing an example of a database, of a basic database. This database has, I'm talking about the Northwind database here. So this database has several tables. It has a customer table, it has an order table, it has a contact table, it has an employees table. Now, for this application, for instance, when this application is being developed, there's going to be a front end, and then there's going to be an API, and then there's going to be a database. Now, when this application was being developed, the API, for instance, on a practical level, was done like this. Yeah. So when this application was done in this way. So this application was done to service customers. This application was also done so that the employees of a company. So let me give an example that we have an app, a startup app called Tuba. So this application is going to be used by customers. There's going to be orders on the application. This application, the employees of this app are also going to log in, and then customers are also going to onboard. So to do this application, we did an API that would service the customers, which is here. We did an API. We did an API that contains a service for customers, which is here. It also contains a service for our employees, which is also here. It also contains a service to onboard both the customers and employees, which is here. You can see there's a sign up here, there's a sign in here. It also contains a service that will take orders from our customers, which is also here. You can see there are several in this API. There are several endpoints for the orders. There's a get endpoint. There's a post endpoint. There's a get orders by ID. There's a put orders by ID, and there's a delete orders by ID. As you're well aware, the get is majorly used to just get, maybe a customer logs into the application and he wants to see, oh, where are all my orders? So this is the one that the customer will call. When the customer wants to make an order, this is the one that the customer will call the post. When the customer wants to get a particular order, he's going to do a get by ID. When the customer wants to probably cancel an order, update an order, maybe he doesn't want the order to be delivered tomorrow anymore, he wants it to be delivered next week, he's making an update. This is the endpoints that the customer will call, that our Tuba customer will call. And then maybe when the customer also wants to cancel the order totally, it's going to call it delete endpoint. So this is an example of an API that we did for this Tuba app to service everything. And this API works fine. Everything is working fine. As you can see, it's live. This is an example of a monolith application. It's an example of a monolith application. Now, that bears in mind, what's the meaning of a monolith application? Monolith application is when everything is in one place. So all these things, all these services are currently in one place. Customers services in one place, employees is in one place, onboarding services in one place, other services in one place. Even the weather forecast is in one place. Maybe we want to add a feature so that our customers can see what is the weather today. And this is working fine. And this is perfect. This is really fine. There's no problem with this. But as an organization grows, you find out that this is not maintainable. This is not maintainable because if you want to change the way the customers are making orders, and if you indeed change the way the customers are making orders, it means that you have to deploy this whole API all over again. And that's not bad, but when you do things like this and you have some errors in, probably make some errors in the orders, it's going to affect this whole endpoint. And then customers will not able to onboard anymore. Employees will not able to do what they need to do. Nothing will happen on this application at all. So while Monolith is good, Monolith has its challenges, one of its challenges in that area. And that's the main reason why the microservice started becoming so popular. So what is a microservice? So how do we now make this to become a microservice application? So just to give you an example of how this application is also written, we have and to try and keep it as hands-on as possible, we have, this is the sample source code of our 2-bar API that has our customer, that has our employees, that has our onboarding, and then also has our orders, and also has our weather forecast. So everything is, everything, all the services are in this one source code. And like I said, everything is fine. This works fine, this works fine. But as you are growing and as you need to make changes in only one services, you are going to affect the other services because you need, so if you make a change in these orders and you add something else to these orders, let's say for instance you add another property, you add another endpoint, and you call it so you call it yes. So I've added another endpoint on the other services, and then let's say for instance I deploy this. And I have it here. So like I said, this works. There's no problem with the monolith. It's perfectly good to do monolith. But the issue is that because you want to update these other services, this update is also going to affect, you need to basically take into consideration that you're going to deploy this whole API all over again. And if maybe at that point in time, maybe a customer is currently making maybe a new person is currently onboarding, they get interrupted, interruption happens, and many things like that. So to explain what microservices is the aspect is the art of making all of these services to stand on their own to become micro. So to start with, I'll give you an example of the onboarding. So this is the onboarding microservice. So as you can see, this onboarding microservice is different from this microservice because in this onboarding services, it has only onboarding as a service that it's powering. I'll give you an example of what it looks like in the code. There it is. So here's the onboarding microservice. Here's the code. As you can see, the only thing that is being done in this onboarding microservice is just the onboarding. And it only has the sign up and the sign in. And in the latest update that I just run, as you can see, there's no other service that is powering here. It's just onboarding. The same thing with the other services, customer. So we also are going to take away this customer service and make it stand on its own and deploy it, and it becomes a service that stands on its own, which is what you can also see here. So in summary, what I'm trying to say is that the basic definition of a microservice is just taking an application and breaking them down into pockets of application, into micro application, into microservices. So that's how the word microservices actually came about. And that is just the basic hands-on definition of a microservice. Now, so another area of microservices that is very, very key to understand is the deployment of a microservice. So as you are aware, when we add all our services in one API, the customers, the employees, the onboarding, the orders, when we add everything in one API, when we want to deploy this application, I want to take it to production, you can just take this whole thing and just take it to production and boom. All these things are available to customers. So it's easy to deploy. But when we now separate all of them into pockets, it means that we have to deploy pockets of applications now. And it's very easy to do that as well. It's very easy to do that with continuous integration, continuous deployment. There are several continuous integration and continuous deployment that we have. It depends on the versioning system that you're using. If you're using GitHub, for instance, there's the GitHub Actions. And if you're using Azure DevOps, there's the Azure CI/CD. So I'm just going to give you a very brief example of GitHub Actions and a very brief example of an Azure CI/CD. Not pertaining to this project, but to other projects that have been done. So this is GitHub, and this is a GitHub action. What is a GitHub action? A GitHub action is at the base. It is just a CI/CD pipeline that will take your application from your repository and host it to the place where all your front-end applications will be able to go. So basically, to deploy the applications for you. So with GitHub Actions, you have the opportunity, you have the pleasure of deploying all your applications, all your microservices, as easy as you are deploying it if it was a monolith. It's very, very important that when you are doing a microservice, you add continuous integration and continuous deployment to your deployment process. If not, it will be very stressful for you to deploy each of all these individual microservices on its own. Each of all these individual microservices, the customers, the employees, the onboarding, and the others, it will be very difficult to be deploying individually. At the moment, most organizations in Nigeria, and funny, but really most organizations still do manual deployment of some of their services. It's not funny really, because organizations don't really like to change. They like to maintain whatever is working. There's this belief in the tech world that when it's not broken, don't fix it. But one of the advantages that don't really they don't really take note of is that if they move on to microservices, they have a lot of tools out there that can make their deployment process really easy. So microservices, there are different types of microservices. To explain these things in a very simple way, these are some of types of microservices that are commonly used. There are more than this, but these are the ones that are mostly used according to some research. Um, one of them is called the API gateway. Then there's a database per service or shared. Then there's a CQRS and there is a Saga microservice type. Now, what does the API gateway microservice means? The API gateway microservice just means that when you deploy your microservice, you need to be able to connect to those microservices. You can connect to those services through an API gateway, meaning that those microservices are going to be seen as an API. That's just what the API gateway means. And I'll share an example of that shortly. The second one is the database per services shared. What that means is that all your microservices are going to have their own database, or they're going to have a shared database. And to give you a quick example of that, our monolith application, which is here, this is an example of its database. The customers, the employees, the orders, everything is in one single database. So what the database per service method of microservices is saying is that each of all of these things will not be in one single database, but they will be in their individual databases. They'll be in their individual databases. And there's a CQRS. CQRS is considered one of the hardest methods of microservice pattern because it has a very steep learning curve. I would not touch much on that because since this is an introductory, since this is an introduction to microservice, I will not touch much on that. But CQRS is basically an event-driven architecture on microservice where a particular service would drop an event for another microservice to pick up. So to give you an example, we have an onboarding microservice. When a customer is trying to sign up onto our application, the customer is going to be calling the sign up service of the onboarding microservice. When the sign up is done, it needs to let other services know that, hey, I've just signed up somebody. So what the onboarding microservice will do is it will drop an event. When this onboarding microservice drops an event, that event is going to be listening on by others who are interested in that. One of the services that would be interested in that is, for example, the customer microservice. I should have a customer microservice standing alone here. Yes. So one of the microservices that would be interested in that, for example, is the customer microservice. The customer microservice will listen to that and say that, hey, oh, I have somebody that just onboarded, this person is a customer, and then the customer microservice would pick up that record and do something with it. Possibly send an email to the customer and says, hey, welcome to Tuba. Welcome to Tuba app for being a customer. These are the perks that you have. These are the things you can do. These are the things you cannot do. So although CQRS is really more than that, but that is a basic example of a way to add event-driven architecture to a microservice. Now, to go back to the API gateway that I was talking about, and to use the example of the onboarding. So, as the onboarding is a microservice on its own, is a standalone on its own. When I am onboarding onto Tuba and I am done, once I am done, this onboarding microservice is going to make an API call to the customer microservice. Where is this customer microservice again? Sorry. I thought I just saw it now. I must have closed it. But the idea is for the API gateway method, once the onboarding microservice is done, the onboarding microservice is going to make an API call to the customer microservice. That is why it's actually called an API gateway. All the microservices are going to be listed as an API. Now, there are advantages of implementing some of this, and there are disadvantages of implementing some of this. For an introductory class, might be out of the scope of an introductory class, but I will just touch on it for a little bit. So for the API gateway method, it is actually the simple, in my own opinion and in many other people's opinion, it is the most simple way of implementing a microservice pattern, because basically as of today, everybody does an HTTP, everybody implements HTTP protocol in the application. The reason why it's not so good is when your application grows, you run into what is called cyclic API calls. Cyclic API calls is a situation where you are going to have to call. So for as an example, when the onboarding is done and it needs to call the customer microservice, but possibly the onboarding also needs to call another microservice, maybe like the employees microservice. So you can have a scenario where an employee is also going to be a customer. So that means that the onboarding microservice is going to have to call the customer microservice, is also going to have to make an HTTP call to the employee microservice. And as the microservices are growing, that means the onboarding will have to be calling all of those microservices as well. So that kind of has some performance overhead. And so that is why, even though the API gateway is the easiest to do, it also has, it's not a way to go for microservice. Okay, yes, this is the So basically, from personal experience and from a lot of documents online, one of the best ways of implementing a microservice is making it event-based. Now, making it event-based, CQRS is there, a Saga. There's just a basic publisher, subscriber. It's just basically what I just explained, that which is event based. So all of these are event based. This is also event based. Event based microservices are where you drop an event and the event is picked up by other microservices and they act on it. Now, there are several ways that you can implement an event-based microservice. You can use, there are several tools out there, like RabbitMQ, which is open source, but sometimes the learning curve for RabbitMQ might be so high. So you can also leverage on using a cloud-based event-based system like AWS or Azure or GCP. For Azure, for instance, Azure has an Azure Service Bus where you don't need to do any configuration. You just drop some messages and the other microservices that need to act on that will just pick it up and do what they need to do. So I'll quickly touch on the upside and downside of a monolith. The upside and downside of a monolith is very fast, very quick, very simple to implement and to start a project with, to start a company with, to start an application with. You don't need to bother about how to communicate with other services, because they all live within each other. So as an example, if I'm writing a code, for instance, for a monolith application, and I'm onboarding a user and I am done at the sign up level. Once I am done, I don't need to be thinking of implementing an event-based system for the other person that I'm going to pass this thing to. They are all here in my code base. I can just decide that, oh, I'm passing it to the employees or I'm passing it to the customers. And it's as simple as that. So monolith kind of gives a very rapid deployment process for an application. And that is very good, especially for startups. Now, this downside of monoliths is just like I explained earlier. The major downside of a monolith is when one service is down, everything is down. I'm very sure that you guys have experienced cases when you can't log into maybe like a banking app or any app that you're using. It's basically because something is down, and maybe something that might be down is not even related to the login. It's related to something else entirely. But because it's a monolith, everything is down. You can't do basically anything. Or for instance, a case where you're already logged into the application and then something is just not working anymore. And then you log out and then you can't log in anymore. So that's the major downside of a monolith application. The upside of a microservice application is basically in this scenario, if the onboarding service is down, the other services would not be down. They would be up. So to give an example, let's say we're on the Tuba application, for instance, and then I am trying to log in, and then there's an issue with the onboarding API. There's an issue with the onboarding service. I deployed a very wrong code, or something happens, or the database is down. So nobody can log in, nobody can onboard. However, the customer, so we have about maybe 500 customers that are already on the app. They are looking at their orders and they're looking at making the orders. There's nothing would affect that other services. So they will still be able to make their order without any interruption. So the order will still be going fine. The only thing that will just be affected is the onboarding, and you can quickly get a team to look at what is happening with the onboarding, and then they can onboarding API, and then they can fix it, and then user can sign in. Another reason why a microservice is also another upside of a microservice is because of the fact that, as you can see now, this application is written in one particular language, for instance. But if I was doing a microservice application where all the services are standing on their own, I can decide to write this in one language. I can decide to write this one in another language, maybe Golang or Java or anything. So that way we're going to have several teams. That way it makes us open to have several teams and not just rely on one language. It gives us the ability to be able to explore the advantages of different language, different frameworks, different strategies to achieve whatever we want to achieve. We're not locked down. So microservices doesn't lock you down in anything at all. You can decide to do it in any, you can decide to use any strategy to achieve your microservice goal. One other thing about microservices, which I don't really want to touch now, but because it's an introductory class, is that microservices are now, one of the upside of doing a microservice now is you can basically containerize your application. Containerizing your application basically means just having a container and putting everything inside that container and taking that container to production. The most popular container right now is Docker. So with Docker, you can basically put your API, your anything that is dependent on the application, you can put it in one container and then just host that thing on production. So microservices really has a lot of upsides in how you are able to scale your application, especially if you're a very big organization and you are currently on monoliths. Now, one of the downsides and the major downsides of microservice is that it has a very steep learning curve. It has a very steep learning curve because doing a microservice is very simple. It's just basically to just do the same thing that you normally do before. So for instance, here now, I have a microservice for the customer. It's just meant to handle only customer interactions. It's just meant to service the customer side of the business. And this is exactly what I used to do before. There's no issue there. But the problem now remains that you need to now start thinking of how this customer microservice would communicate with other services. So how the customer services, for instance, will communicate with the other services, how the customer services will communicate with the onboarding services. You need to start planning that, putting that into consideration, unlike in a monolith where you don't have to even think about anything like that. So this communication introduces complexity to a microservice. And if you don't get it right the first time, then from experience, you spend lots of time just writing that microservice because you will not get things right. You also run into performance issues when you're trying to communicate from one microservice to another microservice. So communication in a microservice is one major issue. Why microservices is a downside to microservices. Why microservices are really not that adopted. And I think the last upside that I would mention about the last downside that I will mention about microservice is I think that's just the major thing I wanted to say. The learning curve and the communication between them. Yeah, and the learning curve also makes it doesn't make a lot of companies to And so these two downside doesn't make a lot of companies to want to delve into microservice because of the downside. But if you look at the upside and the downside, in my own opinion, the upside is really more than the downside, especially for companies that are so big, like banks, fintechs, and so many shit. The only time I would recommend a company to go with monolith is if they are a startup, and that's just my own personal opinion. So, I think that is all I have for introduction to microservice. And if you have any questions, feedbacks on what I just said, I'll just leave the floor open for anybody to come in here. Sorry, I can't hear you very well.
Oh, now can you know?
Yes.
So I explain the of microservice
Sorry, I can't hear you again.
Hello, can you
Okay.
drop your message, your question in the chat box so you can pick it up from there? I think that's better. Thank you so much, Ololade. I think it was actually, quite an introductory and also advanced to some extent. And yeah, I like the way you went with the different, presentations, which is actually very good. Someone is asking a question. It says, in terms of cost implication, which is better and offers better optimized costs? This question is from Chukwuemeka from Kubernetes team.
Okay, wow, that's a very, very interesting question. And I think that question is in terms of cost. So I will label the cost as a composition of financial costs and time costs and maybe resource costs as well. They are really intertwined anyway, because all of them still falls into financial cost at the end of the day. But the way I will answer the question is for a company that is just starting up. Like for instance, I myself, there's a startup that's going to launch ending of this month or early next month. We we considered we wanted to go microservice, full microservice, but we also wanted to launch and go into the market. So because of the cost of time, we went through a monolith approach. Hybrid approach, actually. We finally did an hybrid approach, but for the sake of this, I'll just call it a monolith approach. So for the cost of time, a monolith will be faster, will be better, will be less costly because of time. But for the cost of technical depth, for the cost of the life of the solution. So the word technical depth, I want to use very simple term, but the word technical depth is just like the core depth. No, and for people that don't know, technical depth is a case where an organization's main product has some defects or has some backlogs that is necessary to that they have to do, but they have not gotten around to do it because every day new backlogs keep coming up. So I'll give you an example. For instance, So I have this application now. This is my Tuba API, the monolith one. And I want to, and they've been telling me that, for instance, I should add a delete to the onboarding, that a customer should be able to delete his profile. We've not been able to do that yet, but they've also come to tell us that an employee should also be able to maybe invite another employee. And they come again with another request and says customers should be able to add their family and friends. And we also want to implement other services on this our Tuba API. So all these things I want to implement keep on becoming backlogs. One core reason why it becomes backlogs is because we don't want to, because this is a monolith, we are very skeptical about adding things to it, because we have customers that we're thinking about, we have employees that we're thinking about, we have the sign-up process we're thinking about, and we have our orders that are making us money to think about. So we don't want to disrupt the process. So to add new features, or to work on backlogged features on a monolith application always takes lots of time. If I was doing a microservice application, if I was doing the microservice where I had my onboarding that was standing alone, and I have my other services that are also standing alone, and I have my other services that are standing alone, that's the customer service that stands alone, I would be able to say, okay, I'm not scared that when I add something new to this customer service, everything will stop working. Let's go ahead and do that. I would also not be scared to say, okay, the customers that they say the business is asking us to add a delete function to the onboarding, so that people will be able to delete their profile. Yeah, had it here. I'm not worried about anything that will happen to the customer service, to the employee service, to the other services. So in that way, the cost to scale, by scale I mean the cost to add new features, this cost to expand the business when you are going the microservice way is very low compared to the cost when you are doing the monolith way. Don't also forget that bugs is one of the major things in softwares. There's no company today that doesn't have bugs. Apple, Google, Microsoft, all of them. So if you have a bug to fix on a monolith application that contains all the services in one source code, from experience, and this is from personal experience, it is always costly to fix, because you have to, once you fix it, in probably the bug is in the employee side, and let's say you also have unit tests that you run in your source code, you have to run, let's say you have QA on your team. Most QAs will do a regression test. Regression meaning they will do a test that will test things, that will go back in time to test everything. Okay, so basically regression is they'll basically test everything, all the services, despite the fact that you did a change just on the employee side. Maybe you added a new feature here to say, okay, employees should be able to add their friends and family. But for the QA team, before an application goes live, most organizations, they have a QA team that will test. So when they are testing, they will not only test the new thing that you added, they will also test the onboarding, they will test the orders, they will test the customers. Because in a monolith application, when you make a change in one place, most of the time it affects, most of all those things are also referencing. They might be referencing that file, they might not be referencing that file. So a QA will have to test everything. Whereas if I was doing a microservice architecture, and I make a change in the customer, and I add a feature to the customer that says that the customer should be able to maybe add their family and friend, right? One, the extent of regression that will be done would be minimal, would only focus on this customer. Secondly, there would be little fear that other services are going to crash or something's going to happen to them. So the cost for me, the cost for microservice application to expand is very low compared to the cost to expand when you're using a monolith application. Then there's also the financial area as well. In a way, you might.
Ololade, can you please round up on that question because we still have another question here.
Okay.
Thank you.
So the cost is relative to this, to me, for me, my own side, is relative to the size of the company, and is relative to the is relative to the strategy of the company. Yeah.
Okay, thank you so much. I think we have another question from David in the same team, Kubernetes. He says, can you please explain, the impact on database performance when you have several microservices interacting with a single database, and also compare it with when you have, I think, several microservices with different databases.
Okay. So the impact of in the monolith application, this is the database. Every table is in one database. So it means that when I am logging in and I'm calling the database, when I, a customer, I'm doing something on the application, I'm making a request to the customer table. When Sean, an employee, let's say Sean is an employee and is logging in, is making a request to the employee table on the same database. So it means that the database is going to be servicing so many requests at the same time. Now, most databases can do that. Most databases are designed to be able to withstand multiple requests. However, there are cases when some things might happen. Very few, but there are some things that happen, especially when you have lots of requests, when you're a very large company that services maybe 500,000 requests in maybe 1 minute. There's going to be a lot of hits on the database. So when you shift to a microservice architecture and you're using the database pattern where the database is not shared, obviously it means that in the database, instead of us to have categories, contact, customer, employees, others in one database, we're just going to have in this database, we're only going to have maybe customers, for instance. And in another database, we're going to have employees. So when requests are coming to that microservice application, they're only going to that one database alone. And it's not going to be stressing it out like it will in a monolith application. So that's the advantage of using a microservice application with regards to database.
Okay, thank you. I also have a question. I think it's something I would like your your response on. You were talking about communication between different microservices, and which has to do with API calls. So can you please talk a bit about API security and common checks or attacks that we have when it comes to communication between microservices?
All right, thanks. So one of the to answer that question, I'll start with saying that one of the downsides of using a microservice pattern One of the downside of using microservice pattern is because I have these services here, and I have um, so because I have this my customer microservice here, and I have my onboarding microservice here, they are kind of separate. So it means that I need to implement API security layer onto different microservices. Unlike if I had just one monolith, I will know that I'm just securing this one thing alone. But the advantages of using an API gateway methodology, API gateway pattern, is that you will be able to compose all your microservices under one umbrella, like under one house, under one body. So you'll be able to apply your security to one place, and then that security will cascade through the you cascade down to the all the microservices that are under that body. So, and to do that, there are several ways that one can do that. One of the advantages also, one of the things around microservices is to take advantage of most of these cloud services that are out there. For instance, Microsoft Azure and AWS. So for using Microsoft Azure as an example, Microsoft Azure has a very useful product called Azure API Manager that allows you to basically add all these microservices under one body, and that would enable them to be able to share the same security layer, that will be able to enable them to share the same audit layer, to enable them to share almost the same everything. So, and if you don't want to go through the Microsoft Azure way, there are many other ways that one can go through. You can actually build your own security layer and share it across all the microservices. So I think that addresses your question, if I get it correctly.
Yeah, that's perfect. Thank you for that. And I think Dakwa also has a comment you want to make. Hello, Dakwa, are you there?
Oh, yeah. Can you hear me?
Yes,
Yes.
I can hear you.
Okay. Hi, Ololade. Thank you so much for this comprehensive class. So I just have a couple of questions that I want to ask quickly. So maybe as I'm just taking the questions, you can just quickly answer them. Okay. So the first one is, you have vast number of at least years of experience, when it comes to working with the DevOps team. So basically the question I want to ask is, what are those things to look out for, from the DevOps perspective? What are those things to actually look out for when a DevOps practitioner is working with a dev team? So if you're actually working as a project, like, what are those things that a DevOps practitioner, would have to, ensure that he has, within his sleeves when he's working with the dev team? So you might actually just want to quickly take that. Yeah.
Okay. Yeah. So from my own experience, one of the things that the DevOps engineer needs to look out for when they're working with the dev team is that they need to be able to have some. They should have some knowledge of. They should be able to take over the scripting of most of all this deployment process, so that when the dev is just done and pushes the code to a particular branch, right, they should be able to set up some CI/CD, some continuous integration and process that would pick that code and run some things that they want it to run and basically deploy it, or it should go through whatever they want it to go through. They should also take over the process of monitoring, setting up monitoring for the application. By monitoring, I don't mean manually monitoring. I don't mean doing application support, no. But basically, what I mean is just to set up a monitor on an operations, which is basically an operation task, that if this API, for instance, is deployed successfully, alert this. If this API was not deployed, alert so people. If this API has been deployed, but the API is not now available, also do ABCD. That's one of the things that I believe a DevOps engineer should take over from the dev. Should do with when they are when they are working with a dev on this. Good enough these days. Terraform is really making waves, and for me, I've never seen any application as, I mean, Terraform is so powerful that I'm very new to it, but with what I can see it do so far is just so powerful. It's basically infrastructure as a code. So instead of having a case where we have Azure as a cloud system, and AWS and GCP and any other thing, instead of having the knowledge of each and every of these thing alone, one can also go the Terraform way and use it to build up their infrastructure as a code that would streamline how the deployment process should go, how the alert process I just spoke about should go, and how any other process that they want to do, security, network, how any other process should also go. So that's what I think about that one.
All right, okay, thank you. Okay, so to the next one, we're all aware of the hacking incident that actually happened yesterday on one of the popular, ride-hailing services, talking about Uber, right? They were actually attacked yesterday, and some of the information we got was that, when the attacker, actually revealed some of the loopholes he or she used to get into Uber, and information that we read was that there were some, sensitive information within some PowerShell scripts, that were not encrypted, talking about the DB connection strengths and what have you. Now, what are the best practices, right, that or what are the best practices that as a DevOps practitioner we need to ensure, when working with passwords and DB connection strength? Because definitely within your microservices, be it a monolith or a microservice, definitely you would have to pass some sort of DB connection string to connect to your DB, or even if you have to connect to like a message broker, right? You need some sort of username and password. So what do you think are the best practices, for encrypting, some of the sensitive items within some of this sensitive information within the code base?
Wow, that's a very deep one, and really, it's even funny asked, because we're doing something around this last week, and it was using Terraform actually, where so before now, what I've seen that has been done is that some DevOps engineers, and you know that in the world of tech, there are like 100 ways to skin a cat. There are 100 ways to do something. So this is just one of the ways that I've seen, personally I've seen, and I've also been involved in, where when an application has been doing this continuous integration process of an application, right? There are some checks that are done on the source code. Those checks, some of them are, to check if the unit test is passing. Some of them you should check if the application is actually building and working. One of those other checks is also to check if there's anything sensitive on the source code. There are several out of the box tools that were available then on the cloud system that we're using. But as at now, and which is what I was talking about that last week, one of the things that I was also involved in was that we're trying to use Terraform to actually do that kind of thing as well. So to summarize it, right, my belief is during the continuous integration process of an application deployment, there needs to be some checks, a lot of checks. Unit tests, build is fine, sensitivity, what can this expose us to? Also possibly check what kind of library that is using, check it against a database of libraries that have been reported to not to use, or that have been reported to be malicious, and everything has to happen within the continuous integration process. So that's one thing I believe that DevOps engineers need to need to focus on, and tighten that continuous integration process. Put a lot of rules there, so that if any of those rules fail, then the application is not going to be delivered at all, thereby not exposing anybody to anything. I don't know if that makes sense.
Yeah, yeah, it does. Okay, so one last one from me is, we have so many DevOps practitioners online, as well as aspiring DevOps practitioners as well, right? And the myth or the methodology that we've been hearing all over is a DevOps practitioner must learn how to program, right? You must learn how to, write code and all of that. Exactly. So now, we have guys that are actually confused on that. So what advice, or let me just frame it this way. What is the programming language, that you would advise for aspiring DevOps practitioners to learn? Because obviously you must not know, because what I usually used to tell people is you must not know how to program, you must not know how to write a code for you to be able to deploy an application. But the most important thing is to at least understand what it does, by understanding the build steps. You talked about unit testing, integrated testing and what have you. So what is the limited, let me not even put limited, what do you think, in your own opinion, is the best programming language to at least learn that is very much more aligned with DevOps? Thank you. And that'll be all for me.
Oh, thank you. Wow. I like that question, though, really. For me, I think it's scripting language. The ability to script, PowerShell scripting, and any other scripting will give anybody the ability to be able to even pick up another language and just write something that they need to write on that language if it's necessary. But from what I've seen so far, most of the DevOps, most of the cloud systems that are currently powering DevOps are very, very heavy on scripting. So they can use scripts to do basically everything from setting up the CI/CD pipeline, from setting up some YAML files, from setting up basically everything that they need to set up. And I really don't think DevOps engineers need to learn how to write code, because the DevOps, the cloud system itself, at the minimum, at the base, right? There's this thing that they call the cloud system, that they are based on JSON. Everything around them is JSON if you look at it. Meaning that if, for instance, now you log into AWS through maybe a CLI, that's a command prompt, a terminal, and you start, or let me say Azure, because I'm more familiar with Azure, and then you start sending some commands to the Azure, and then the command starts returning response back to you. What I've seen is that most of those responses are really JSON at the end of the day. They are just JSON at the end of the day. So all your configurations in Azure, I know, are saved in JSON. It's just that the JSON can be very bloated, very long, very fast. Like let me use the word fast. Very verbose, but let me just use the word fast or just a generic word. So they can be very fast, but at the end of the day, they are JSON. And since they are JSON, I believe a very basic scripting language will suffice to be able to update maybe a resource that you want to update, delete a resource, create a new resource, or create a new task that you want to happen on the cloud system. But it doesn't. But at the end of the day, still, it doesn't hurt if a if one picks up a programming language. And from what I've seen personally, or myself, I'm more of a .NET person than any other languages. But from what I've seen so far, most of the people that I'm seeing are mentioning Golang as the language of choice to do a lot of things on DevOps. I think that's also evidenced by the fact that Terraform was really written in Go, and some part of, according to what I read, some part of AWS was also written in Go. I'm not sure about that, but I read it. But I know that Terraform have said it on their official website that it was actually written in Go. But at the basic, scripting language would suffice for anybody, DevOps, or even a normal engineer should also learn scripting language. So
Okay.
that's my answer to that.
Thank you so much. Thank you. I think what you said, the last comment is actually very correct, which has to do with Go language, because right now we have even DevOps engineer moving into open source programming, and
Yeah.
some of these tools they want to create, they don't actually need to be too deep into software development, and they need to learn one or two language, and even Kubernetes was also written in Go language. So thank you so much. Thank you very much for your time. And Oluwaseun, are you there? I'm going to hand over to you now.
Yeah, he's meant to take Git also. Ololade, the Git. Are you taking us on Git?
Okay. Yeah. So
Maybe just 5-10 minutes. Just
okay.
yeah, so that we can have time for questions from the participants.
Okay. All right.
Please, let's give him more time, because he may want to spend more than 5-10 minutes on Git. So just go on. Thank you.
Okay. So microservice are applications. Like, this is just an application that is just meant to, to do, like, this is my customer service. This is my customer application. It's just meant to service my customers in my application.
Hello?
So as my customer,
Hello, sorry, Ololade. So sorry for
yes,
cutting it this way. We
sure.
have one more question from David. Do you really want to take that quickly?
Sure.
Yeah, okay. So he's asking, when you have two microservices named order and customer, how do you get all orders from the order service for a particular customer ID on the customer service?
Can you take that question again, please?
Okay, you have two microservices named order and customer.
Yeah.
Now he's asking, how do you get all orders from the order service for a particular customer ID on the customer service? I think this has to do with more like an SQL query sort of.
Okay. I think how do you get an order from an order ID for a particular customer? Yes, particular customer. Yeah. So one of the basically that is talking about communication between the microservices. How does those microservices communicate with each other? How does those microservices share data with each other? And one of the very steep thing about microservices is the data synchronization amongst them. That's why most of the time when some people start microservice, they go with the shared database option. But if they go with the database per service, that means that the order will have its own database, and then the customer will have its own database. So what Davis is asking is, for a customer, we want to get the order of that customer. So we can add the minimum if we're using the API gateway method, right? We will just call the order services. All right, okay, I don't have. So we'll call the order services, and then we'll pass the customer ID to the order services. That's okay. Give me the order for this particular customer. So it's just be an HTTP protocol way. Or it could also be, we could also use that event method as well, where we just drop an event for the order services to return the order of a particular customer. So I think those are very simple ways that we can even achieve that without even going through very advanced ways of CQRS or Saga or any other thing. So one is the API method. Just make an API to the other microservice, and the other microservice will return response back to you. The other one is to just drop a message, drop an event for the other API, and then the other API will pick that event that, okay, you need information about this person, I'm going to give it to you. I don't know if that makes, I don't know if what I said, I don't know if you can hear me, David. Hello?
Yes, boss. Thanks for the explanation. It's clear now.
Okay. Okay. So talking about Git, I like to approach Git from a very basic place. So we have our APIs, we have our code, we've written our code. Now we want to this code is basically on my system, and we're a team of let's say we're a team of two. We're a team of two developers working on this, or three developers working on this customer service. So basically, I need to put this code in a place where all the devs can access this code base. And the most popular way of doing that is using the versioning system. Git is a versioning system that helps us to version our code base. So one of the most popular versioning repository system is called GitHub, which I'm sure that we are all aware of. Is there anybody here that never heard about GitHub? But I'm sure we've all know GitHub very well. There are many other ones anyway, actually. I mean, I think what I want to ask is that there's GitLab, there's GitHub, there's GitLab. They are all systems that encompasses that encompasses Git. Now, so using Git in a microservice is not even something that's up for discussion, because there's no way.
Hello, Ololade.
Yes.
Yeah, sorry for breaking you. How do you mean versioning, or what do you mean by version? Just need you to share more light on it so it'll be clear. Thanks.
Yes. Yeah. Thank you. I would share a hands-on approach on an example. I'll use an example. Like I said, I don't really like to use slides. I like an hands-on approach. So let's say I have a code. Let's say I have this my monolith application, and I want to I want to Git it. I want to deploy it to Git. I want to put it in a place where is currently on my system. I want to put it in a place where other people have access to it. So, and I choose to use GitHub as my versioning system. So I would publish it to GitHub now. I hope you can see my screen.
Yes, I can see your screen.
Okay, so I've published it to GitHub now. I will go to my GitHub. And here it is. I have my application here. And one thing that most of these repository services gives you is the ability to be able to invite collaborators. People will come onto your listing. So I'm the only person right now on it, so I can add people, and then people will come onto this code base, and then they have access to this code base. So now, but I'm meant to work on. So if you look at the code base, there's the let's say this is the monolith one. Yeah, so this is the monolith one. So I'm meant to work on the customers. Maybe Sean is meant to work on the employee, Lawrence is meant to work on onboarding, and then David is meant to work on others. So what I would do is I would create my own version of the code base. And I will call it, I'll give it a name. Maybe I want to add customer relation that I talked about. So I have created my own version of the code base now. I've created my own, I've created my own, that's only what I can do. I don't see the version. So I've created my own code base. I've taken that code base and I've done something that will make me to do the work I want to do. That's called the version. I've created a version of that code base. But I created the version of the main code base. So now that I've created that version now, I can start doing everything I want to do. So let's say for instance now on the employees, let's say on the employees, I now do something like I now had a method called git my record. So I have this now, and then I will I added this to the employee. Let me just maintain my explanation that I added this to the customer. So I'll just add a message just to let people know that okay, I've added a particular something. So I just added a method called my records. So, and I will save. And once I save this, I would push. There's no other word I can use but push. What I mean by that is that if you check on our versioning system, I have another version of the code sitting here, different from the original version that I have, which is sitting here. So this is they are called branches. So this is a branch, this is another branch. So I have another version here. And this version is the one that contains what I just did. And the message that I added to it, you can see it here. Added a method called delete my record, updated 1 minute ago. The other ones were updated 5 minutes ago, and there's nothing that's untouched there. If you go back to the main version of the code, it has no updates, meaning it's only my own version that has an update. So that is the basic definition of what I mean by versioning. So I have two different branches of this thing. I have two different versions of the source code now at this point in time. So I don't know if that answers.
So
I don't know
what
if that
you
answers
mean
the
basically
question.
is that so what you mean basically is that when you versioning means when you make a modification on the original source code.
Yes.
Oh, okay.
Yes. So when you make a modification on the original source code,
So
and
the
you
okay,
and you
continue
have
please.
when you make a modification on the original source code and you make it in a you make it and then you push, Git would maintain a version of the update.
Yeah.
Git will maintain a version of the update. So it doesn't necessarily need to be on a different branch. And that's one very powerful aspect of Git. It doesn't necessarily need to be on another branch. It can also be on the same branch. The reason why and let me also just show that the reason why I went to another branch is just because of habits. We generally don't want to write anything on the master. But if you also do it on the master, for instance, and maybe in the master, I now want to add something to the employee. I now added delete add an employee friends family, and then here I now had, let's say I now make sure that it's very known that I just want to add an employee friends and family. I'll explain what this, I don't think I should explain what this is now, but this is just a route in APIs where it specifies the endpoints, so to say. I don't need to add this, but it helps for some other things that I don't want to go into at this moment in time. So I've added this, and I've added this on the master. And in my message, this message is just something to make me remember, to make me know what I did at this point in time, like a note. Yeah, a note. So I just added this to employees record, and then okay, so I've pushed that, and then if I come back to the master, and then I come to the history. So first of all, as you can see from here, you can see that this file has been updated and the update message is already there. Add this to employee file. So that's one of the advantages of using that message. It makes anybody remember, oh, what was done at this point in time. Because in other cases, you won't just add one method, you might have like 10, 20, 30 methods to something, but you have to write down. It's best you write down what you did so that if you come back to it 6 months from now, you just remember what you did. So if I should check the history of what I've done, you can see that I have several things called commits here. Basically, this is a version of the code base. This is another version of the code base. So
Perfect.
this is its original version. It is still there. If I want to go back to it, I can go back to it. This is it. This is the original version of it. There is no update here. And if I now want to maintain the current version that I have, here it is. If I want to view it, I can view it here as well. So this is just what I mean by Git will maintain all your versioning for you. So it is a very strong versioning system that you really cannot do without when you're writing any code, be it monolith or microservice, especially microservice, any code at all. So so that's what I mean by versioning.
Makes sense. Thanks.
Git is like I said, Git is used by a lot of versioning providers. GitHub is one, GitLab. There's so many. I really cannot really bring them out. GitLab is another one. So Git is just like you say, yeah. So Git is just a part of the DevOps process, because DevOps engineers would be able to use this versioning to specify the particular code base that they want to go in a particular environment. So for example, most of the time, most DevOps engineers, most companies would keep the master branch as a source of truth, where this is the one that a DevOps engineer would create some scripts, we call it scripts, some integration pipelines that will be listening on this master branch. And when there's an update on this master branch, some things will start to happen. They might also create some tools that will listen to other versions of this code base, possibly looking at it on a branch level. So Git is really embedded in the old DevOps cycle. It's something that we can't do without in the old DevOps cycle. And so that's just a very simple hands-on explanation of hands-on talk of the whole of Git at this point in time. Sure.
All right, thanks so much, Ololade. We deeply appreciate taking it from the very, very basic and bringing us to this level. Thank you for your time. We deeply appreciate it. And we'll be expecting, like typical of our practice, the assignment to be shared once it's available. Is already informed about the assignments for each team. So the task assignment to carry out for the week will be dropped on our Discord channel so that we can all prepare for it. We'll be presenting it on Friday. And that will cover all that we've done, just to help us more of like rehearse with all we've been taught today. So let's just get ready for it. Dakwa, I don't know if you have additional information you want to pass across. So you want me to make mention of them. Dakwa, is still on the call?
Yes, I'm on the call. All right, so very quickly, let me just appreciate Ololade, Oyebanji. Thank you so much for the detailed. I think if you could actually see my notes right now, my notes is actually full, right? And like you've been able to, pass the required knowledge, to all the mentees. And I'm sure that even my fellow co-founders as well, they've been able to grasp one or two things, within this workshop. So thank you so much. It was so detailed because I was just imagining that how do you want to, cover all of this within the slim time that was given to you, but at least you're able to do justice to it, really. So thank you so much, Ololade, and we'll be looking forward to seeing more of you. I think I'll forward our Discord link to Seun so that Seun can forward to you, because I'm sure that we'll still have some other mentees that would want to ask questions. We're actually more than this. I think we're over 60, but some might not really be available, and they might actually want to rewatch the recording and ask questions, so that once they ask questions, right, you can always help out to do justice to the question. So thank you once again. on behalf of the mentees and my fellow co-founders, I say thank you so much, Mr. Ololade. And this is to all mentees. So next week, we'll be delving into, okay, just like Sheo mentioned, we would have another round of team presentation next week. We should get our assignments this evening so that we can start meeting in our respective teams to do justice to the assignment. So next week, Friday, same time, 7 p.m., we'll be meeting. If possible, Ololade will be on the call as well, so that at least you can see how far we've gone with the assignments. That would happen next week, Friday, by 7 p.m. to 7:45 p.m. Then on Saturday next week, we'll be moving to Python, right? We'll be moving to Python, just the basic understanding of like the basic requirements of what is needed, to learn using Python. Really, so we'll be moving to Python by next week, and we'll also share the materials, that you need to, start reading. You need to start watching before the class. And then upper week is we're going to be taking a break, right? Upper week, because it's been back to back since July, and we are almost into October. So we'll be taking a break next upper week so that we'll refresh, we'll relax, and then we'll resume again powerfully into cloud, configuration management tools, Docker, Kubernetes, CI/CD, and what have you. So that is the brief information I have. So once again, thank you so much, Ololade, and we appreciate the time and the efforts that you actually put into this. All right, so that will be all from me,
Thank you so much. Thank you so much, guys. Thank you so much, everyone.
All right. Yeah. Thanks so much, everyone. Thanks for those that are newly joined us today. Maybe you've not been part of the session. You just joined for the very first time. We appreciate you. Thanks for, giving us your time. And we always have our sessions every weekend, like we said, and we have a discussion where we meet and we give our mentees opportunity to have serious intimate engagements with the faculty leaders, where they can be mentored, or any question, whatever questions they have, even if they have things relating to interview of DevOps opportunities, interview for DevOps opportunities. We have that opportunity. We've created that forum for our mentees where they can meet. They meet with one another and also meet with the faculty leaders. So thanks everyone. Thanks everyone.